All right, everybody, welcome back for another deep dive. Today we're going beneath the surface, literally, to explore a world that's often hidden in plain sight. We're diving into the fascinating world of train tracks.
That's right, but not just the steel you see on the surface. We're going deeper, digging into the engineering marvels that keep those trains rolling smoothly.
You know, I have to admit, I always thought tracks were, well, just tracks. But after going through this technical document we've got our hands on, let me tell you, there's a whole lot more to it than meets the eye.
Oh, absolutely. It's a classic case of out of sight, out of mind. Passengers are so focused on their destination that they rarely, if ever, think about what's happening beneath those wheels.
Right. And one of the things that blew my mind was this whole concept of slab track. I always picture those classic tracks laid on a bed of gravel, what they call ballasted track.
Yeah, the traditional method.
Exactly. But concrete slabs, that's a whole different ball game, isn't it?
It really is. It's almost like choosing between a gravel driveway and a smooth, paved one, but on a much grander scale and with much higher stakes.
And with tons of steel hurtling over it at high speeds.
Yeah.
So what's the advantage of going with concrete slabs for train lines? What's the big sell?
Well, think of slab track as the low-maintenance option in the world of railways. Less at keep, smoother rides for passengers, and here's the kicker. According to the source, they can last up to 50 years.
50 years. Wow, that's like twice as long as those traditional ballasted tracks.
Exactly. Double the lifespan, which you'd think would make it a no-brainer, but of course there are always trade-offs.
Yeah, I was just going to say that sounds almost too good to be true. What's the catch?
Oh, the document is very upfront about this. That long lifespan comes at a cost, a hefty initial cost. Plus, imagine having to repair a giant concrete slab under a working railway line. Logistically, it's a nightmare.
Oh, I can only imagine. That's a whole lot more complicated than, say, just swapping out some gravel.
You got it. And the source even mentions that engineers are still trying to figure out the best way to tackle those kinds of repairs with slab tracks.
Wow, it really makes you appreciate all the unseen complexity that goes into something as seemingly simple as train tracks.
And speaking of complexity, I have to admit, this whole idea of track defects kind of blew my mind.
Yeah, you'd think tracks are, well, fixed, right? Exactly, the name kind of gives it away. But apparently, it's not that straightforward. This source goes into detail about how train tracks, despite being made of steel, are constantly shifting and changing under all that weight and pressure.
Exactly. Think about it. You've got these massive trains, sometimes pulling hundreds of tons of cargo, rumbling over these rails day in and day out. It's bound to have an impact.
So we're talking wear and tear on an epic scale.
Exactly. And it's not just the weight either. You've got vibration, changing weather conditions, even the ground itself settling over time. All these factors contribute to what the source calls track defects.
So what kind of shifting are we talking about here? I mean, are the tracks visibly moving?
Not exactly visible to the naked eye, but definitely measurable. The document talks about these different categories of defects, like there's longitudinal defects, which is basically when the ground beneath the tracks settles unevenly.
Hold on, so one side of the track might sink lower than the other. Isn't that a bit of a problem?
It can be, especially if it's not addressed. And then there's something called track twist, which
Track twist. Okay, that one sounds a little self-explanatory, but I don't even want to imagine what that looks like in real life.
picture a playing card that's gotten a bit warped in the middle. That's essentially what can happen to sections of the track over time.
Okay, now that just sounds terrifying. You try balancing anything on a warped playing card, it's not going to end well. We're talking about trains here, not toys. How in the world do engineers even begin to tackle that? So how do they even begin to tackle track twist? I mean, is it even possible to fix something like that?
Well, they don't necessarily fix it in the sense of bending the track back into perfect shape.
Uh-huh.
This document talks about how engineers take more of a management approach.
Management. So they just, what, accept that the tracks are going to warp and twist a bit?
It's more about understanding how those defects are progressing and then intervening at the right time to prevent them from becoming major issues.
Okay, so it's all about staying one step ahead of those tiny imperfections.
Exactly. And that's where things get really cool. The source talks about all this incredible technology that's used to monitor track conditions, like something straight out of a sci-fi movie.
All right, now you've got my attention.
Yeah.
Give me the rundown on this futuristic train tech.
So, picture this. Special recording vehicles equipped with all sorts of high-tech sensors and measuring devices travel along the rails, scanning every inch for even the slightest deviation.
It's like giving the tracks a full-body scan, right?
Yeah.
Looking for any potential trouble spots before they become major headaches.
Precisely. They're analyzing all the data from these scans, looking for patterns, trends, anything that might indicate a developing issue. And then, based on that information, they can make informed decisions about when and where maintenance is needed.
That makes a lot of sense. Catch those problems early before they turn into major disruptions or, even worse, safety hazards.
Exactly. But it's a balancing act, right? I mean, all this technology, all this monitoring and analysis, it can't be cheap.
Yeah, that's what I was thinking. There's got to be a trade-off somewhere. I mean, how do they decide when it's actually worth it to, dig in and fix something versus just, I don't know, keeping an eye on it for a while?
You've hit on a key point. The document talks about this constant balancing act between cost and performance when it comes to track maintenance.
So walk me through that. What factors go into that decision-making process?
Well, think about it like this. You wouldn't ignore a strange noise in your car engine, would you? Especially if you rely on your car every day to get you where you need to go.
True. You don't want to wait until it breaks down completely and you're stranded on the side of the road.
Exactly. So with train tracks, it's about assessing the risks. The source mentions things like the volume of traffic on a particular line, more trains equal more wear and tear.
Right. Makes sense. More stress on those subtle imperfections we've been talking about.
Precisely. And then there's the speed of those trains, the type of cargo they're hauling, even the weather can play a role.
Wow. So many factors to consider. It really makes those we're experiencing delays due to track work announcements hit differently. It's not just some random inconvenience. It's all part of this intricate dance of keeping things running safely and smoothly.
Exactly. It's about being proactive, not reactive. Because when you consider the potential cost of a derailment, not just the financial cost, but the impact on safety, the environment.
Right, because cleaning up a derailment is a whole other level of complicated, not to mention dangerous. Suddenly, a few minutes of delay doesn't seem like such a big deal. But you mentioned the environmental impact. I have to admit, I'd never really thought about train tracks having an environmental footprint before.
It's not something most people think about, but it's definitely a factor. For example, remember those different track types we talked about? Ballasted versus slab? Well, the document points out that concrete slab tracks, while they offer those benefits of longevity and reduced maintenance, can actually be noisier than traditional ballasted tracks.
Really? That seems counterintuitive. You'd think concrete would be quieter than a bunch of loose rocks.
You'd think so, right? But it turns out that the way sound waves interact with those materials makes a big difference. Noise pollution from train tracks is a legitimate concern, especially in urban areas where you have lines running close to residential neighborhoods.
Wow, I had no idea. So it's not just about cost and performance, it's about minimizing the impact on the surrounding communities as well.
Absolutely. It's a great example of how engineering decisions often involve balancing a whole range of factors, some of which might seem to contradict each other.
Okay, so we've talked about keeping those tracks in tip-top shape. But what about the trains themselves? We've covered how the weight of trains puts stress on the tracks, but I'm curious, is there anything in the source about how passenger behavior, how we ride the train, might play a role? So you're telling me that just by riding the train, I'm adding to the wear and tear. Now I'm going to feel guilty every time I buy a ticket.
Well, it's not about any one passenger, of course, but collectively, our weight does have an impact.
Right. Right. Makes sense. The more weight on those tracks, the more those imperfections are going to, well, I guess, get emphasized.
Exactly. The source even talks about how passenger load during peak hours, when the trains are packed, can exacerbate those track defects we've been discussing.
So rush hour is not just a pain for commuters, it's a pain for the tracks themselves.
You could say that. And it's not just the number of passengers either. Even how we distribute ourselves within the train can have an effect.
You mean like everyone crowding into one car? Okay, guilty as charged. I've definitely done that to try and snag a seat.
We've all been there, right? But yeah, it's interesting to think about even those little choices, like where we stand or how we move about, it all affects the load distribution on the tracks.
Wow, I had no idea. I'm going to start paying more attention to those. Please move to the center of the car announcements from now on.
It's all connected, right? We tend to think of train tracks as these fixed, unchanging things, but the reality is they're constantly responding to forces, large and small.
My mind is officially blown. This deep dive has been quite the journey. We started with concrete slabs, explored this hidden world of track defects, even touched on the environmental concerns. Who knew there was so much to learn about the world beneath the rails?
It's a perfect example of how even the most commonplace things can hold these hidden depths. And really, it's a testament to the ingenuity of the engineers who keep everything running smoothly.
Absolutely, well said. So next time you're on a train, maybe take a moment to think about all those incredible forces at work beneath you, keeping you moving safely to your destination.
It's a symphony of engineering, isn't it? Often unseen, but always essential.
Yeah, I couldn't have said it better myself. And on that note, we're going to wrap up this deep dive. Thanks for joining us on this journey beneath the rails. Until next time, keep those questions coming. And remember, the world is full of fascinating things just waiting to be explored.